Ancient builders accomplished feats that defy our modern understanding of engineering. From the pyramids of Egypt to the stone walls of Peru, these structures are monuments to forgotten knowledge. By the end of this journey, you will discover 25 hidden methods that modern science still cannot fully replicate. How did civilizations move 80-ton statues without machinery? And what is the secret behind concrete that repairs itself for 2,000 years? What forgotten skill do you believe would most benefit our world today? The sheer scale of ancient ambition is humbling. These master builders worked with a profound understanding of the world around them, a knowledge born not from computers but from centuries of watching the stars, feeling the earth, and learning the hidden properties of stone and water. For them, engineering was as much a spiritual act as a physical one. A pyramid was not just a tomb but a stairway to the heavens, its angles precisely aligned with cosmic bodies. A stone wall was a tapestry of interlocking strength, each block a testament to a relationship with the natural world that we have largely forgotten. To unravel their secrets, we must step outside our modern assumptions and appreciate a different kind of genius, one woven from observation, tradition, and a deep reverence for the universe. This foundational wisdom gave rise to specific, breathtaking techniques, and our journey begins with one of the most iconic and enduring mysteries of them all. At the fortress of Saxehuaman, stone walls rise like a puzzle crafted by giants. Each block is a unique, irregular shape, some weighing over 100 tons, yet they are locked together with a seamlessness that defies belief. The joints are so tight that after centuries of earthquakes and weathering, you still cannot force the edge of a credit card between them. This was not a matter of simple stacking. It was a high-precision art form executed on a colossal scale, without the benefit of iron tools or powered machinery. The process began deep within quarries, where these monumental limestone blocks were first freed from the earth. How they were moved across rugged terrain remains a subject of debate, with theories ranging from log rollers to complex rope systems harnessing the power of hundreds of workers. But the true mystery lies in the final fitting. Each stone was individually shaped, its neighbors carved to receive it in a slow, deliberate dance of trial and error. Some researchers propose that ancient artisans possessed knowledge of plant-based chemical agents, substances that could temporarily soften the rock surface, allowing for finer shaping and a more perfect, almost fluid, merge between blocks. This was not brute force. It was a profound conversation with the material, a deep understanding of its granular structure and stress points. The result is a wall that moves and breathes as a single entity during seismic activity, its interlocking teeth dissipating energy that would shatter a rigid, modern construction. We are left to wonder at the patience, the generations of accumulated skill required to fit these stones by hand and eye alone. This mastery over rock finds a strange and beautiful parallel in a material that seems almost alive, a concrete that can heal its own wounds. While the stones of Saxehuaman stand as a testament to a mastery of form, another ancient innovation mastered the very essence of matter itself. Submerged in the Mediterranean Sea for 2,000 years, the concrete piers of ancient Roman harbors endure, their surfaces still solid against the relentless waves. Modern concrete structures in the same saltwater environment would have crumbled to rubble in mere decades. The secret was not just in what the Romans used, but in the brilliant chemical conversation they initiated within their mixture. Their concrete was a trinity of materials, combining lime, volcanic ash from a specific region called Pozzuoli, and seawater. When mixed, this combination triggers a remarkable process. Over time, exposure to more seawater actually strengthens the material, causing tiny, intricate crystals to grow within any microscopic cracks that form. It is a living material, one that actively heals its own wounds. Modern scientists, armed with advanced tools, have only recently begun to decode this self-repairing mechanism. They can identify the specific mineral formations, but consistently recreating the Roman recipe on an industrial scale has proven incredibly difficult. The ancient method was not a single formula, but a deep, systemic understanding of how these natural ingredients would behave and evolve over centuries. This reveals a level of practical chemistry that rivals our own, achieved through generations of observation and refinement rather than laboratory experiments. It forces us to reconsider the very timeline of technological progress. If they could engineer a material that outlasts civilization itself, what other impossible feats of movement were within their grasp? How did they transport the very stones used to build their eternal city? The same principles of intuitive physics that created self-healing concrete were applied to one of history's most perplexing logistical puzzles, the movement of the great Moai statues on Easter Island. These colossal stone faces, some weighing over 80 tons, stand in silent rows far from the quarries where they were born. For generations, the question of how they traveled miles across the island's rugged landscape without wheels, metal, or large animals has captivated and confounded researchers. Oral histories passed down speak of the statues walking, a poetic clue that modern science has only recently begun to take literally. Experimental archaeologists have demonstrated that a small team with a system of ropes can indeed rock a mid-sized Moai replica from side to side, creating a slow, stuttering walking motion. The theory is compelling, suggesting the islanders used a combination of leveraged pulls and coordinated human effort to make the statues seem to stride to their ceremonial platforms. Yet, taking this theory from a small-scale experiment to the reality of moving an 82-ton giant presents a staggering gap. Modern attempts to replicate the full journey often resort to steel supports and heavy machinery, just to prevent the monolithic figures from cracking under their own immense weight. This highlights a profound disconnect. The ancient islanders possessed a deep, practical knowledge of balance, friction, and rhythm, an intuitive physics refined through generations of trial and error. They understood not just how to move the stone, but how to move with it, in a delicate dance of coordinated force that our technology-reliant methods struggle to emulate. This mastery over moving Earth's heaviest objects finds a strange echo in another ancient skill, the ability to move something seemingly intangible, the very flow of water itself, with impossible precision. The silent, patient movement of water finds its counterpoint in the silent, patient observation of the sky. High above the earthly struggles of moving stone and mastering concrete, another form of ancient engineering was taking precise shape, one that oriented entire civilizations within the cosmos. From the stark plains of Salisbury to the vast Egyptian desert, monuments like Stonehenge and the Great Pyramid of Giza were not merely built upon the land, but were carefully calibrated to the movements of the sun, moon, and stars. The Great Pyramid's sides are aligned to the 4 cardinal directions with an error of less than 1/15 of a degree, a precision that would be challenging to achieve today without modern surveying equipment. This was not guesswork, it was the result of generations of meticulous sky watching, a tradition of recording celestial patterns that likely began with simple markers in the earth and evolved into these colossal stone computers. Without written records as we know them, this knowledge was encoded in the architecture itself, a permanent physical calendar and observatory. the builders understood the subtle wobble in the Earth's axis, a 26,000-year cycle known as precession, and designed their structures to account for these slow celestial shifts over millennia. Modern attempts to replicate these alignments using only the primitive tools available to these cultures, like simple sighting rods and knotted cords, consistently fall short of the original's breathtaking accuracy. This gap suggests a level of empirical science and mathematical intuition that we are still working to comprehend. It implies a methodology refined over centuries, passed down through an oral tradition that treated astronomical knowledge as sacred. The grand, cosmic scale of this engineering finds its perfect, intricate echo in the creation of objects so small and detailed that their craftsmanship defies the limits of human sight. There is a legend of blades that could slice through a silk scarf falling through the air, yet bend 90 degrees without snapping. These were the legendary swords of Damascus, forged from a material known as Wootz steel, whose secret recipe has been lost to the flames of time. The mystery is not merely one of sharpness but of molecular architecture. Modern analysis of surviving blades reveals a startling truth. The metal contains carbon nanostructures, microscopic tubes and wires that formed a super-strong internal skeleton. This was not an accidental discovery, but the result of a precise and sacred metallurgical ritual. The process began in India, where iron was smelted with specific woods and leaves in a sealed clay crucible, creating a raw steel ingot shot through with a high carbon content. This Wootz ingot was then the canvas for the Damascene smiths. Through cycles of careful heating, slow cooling, and a specific pattern of hammering at just the right temperature, they coaxed these incredible internal structures into existence. The result was a blade with a visible, flowing water pattern on its surface, a direct map of its complex and resilient internal grain. Contemporary metallurgists can identify the components, yet consistently recreating the process fails. The precise temperature gradients, the exact composition of trace minerals in the original ore, even the rhythm of the hammer strikes, all formed an unrecorded symphony of art and science. Modern industry, for all its precision, cannot easily duplicate this fusion of intuitive craft and emergent material science, a reminder that some formulas are not just written down, but are felt in the hands and seen in the fire. This mastery over the very essence of metal finds a parallel in a mastery over the most fundamental element of all, the earth itself, and the mysterious methods used to shape it on a monumental scale. Granite obelisks represent a pinnacle of ambition carved from the earth itself. These needle-sharp monuments, each a single piece of stone weighing over 300 tons, began their life deep within the bedrock of quarries like Aswan. The challenge was not merely to break the stone, but to do so with surgical precision. Workers employed a method that seems almost meditative in its patience, hammering away with balls of dolerite, a stone harder than granite, to pulverize a narrow channel around the desired block. For the most stubborn granite, they may have used thermal shock, building fires along the intended fracture line and then dousing them with water, exploiting the rock's own structure to make it split itself apart. This was not a violent explosion, but a carefully controlled conversation with the material, guiding it to separate along a preordained path. Once free, the real artistry began. How do you polish a 300-ton needle to a mirror finish without industrial sandpaper or power tools? The answer lies in abrasives. Craftsmen used progressively finer sands, combined with water and a tremendous amount of labor, to grind the surface to a shimmering smoothness over months or even years. Modern experiments confirm this is possible, yet they consistently fail to match the speed and flawless consistency achieved by the ancient artisans. There appears to be a lost nuance, perhaps in the specific type of sand used, the exact pressure applied, or the rhythmic technique of the polishing teams. This was a knowledge written in muscle memory and tradition, a skill so refined it allowed them to treat granite as if it were soft clay. The sheer logistical feat of then moving these perfect monoliths hundreds of miles hints at another layer of forgotten genius, one that required a profound understanding of balance and friction on a scale we can scarcely comprehend. High above, where wood meets sky, a different kind of resilience was being engineered. Across China, pagodas and temples built entirely of wood have withstood the test of time and the violent shaking of the earth for over 1,000 years. Their secret was not found in rigid fasteners, but in their deliberate absence. These structures were masterpieces of intricate joinery, assembled without a single nail or drop of glue. Instead, craftsmen used a complex system of interlocking joints, primarily the mortise and tenon. A tenon, a protruding tongue carved at the end of one beam, would slide perfectly into a mortise, a hollowed-out slot in another. This created a connection that was firm, yet allowed for a subtle, controlled dance between the wooden members. When an earthquake struck, a rigid metal-nailed structure would fight the forces, often leading to its own destruction. But these ancient wooden frames were designed to sway, to absorb and dissipate the seismic energy through a symphony of tiny shifts and groans within their joinery. The wood itself became a living, breathing shock absorber. The precision required was staggering. Each cut had to account for the future behavior of the wood, its seasonal expansion and contraction, and the complex vectors of force that would travel through the building during a tremor. This was applied geometry of the highest order, a knowledge passed down through generations of artisans who understood wood not as a dead material, but as a dynamic partner. Modern engineers can analyze these joints and admire their brilliance, but replicating their longevity and seismic performance using the same hand tools and natural timber presents a profound challenge. We have stronger materials, but we have lost the deep, intuitive dialogue with the material that allowed these builders to create structures that move in harmony with the earth. This same principle of working in harmony with natural forces rather than against them guided another civilization to achieve the impossible, not with wood but with water in the heart of the desert. Deep beneath the rolling hills of Cappadocia, entire civilizations thrived in a world of their own creation. These were not simple caves, but vast subterranean metropolises, some descending over 18 levels into the soft volcanic rock known as tuff. The largest of these, Derinkuyu, could shelter up to 20,000 people, complete with living quarters, stables, churches, and wine presses. This was not a temporary refuge, it was a meticulously planned underground city engineered for long-term survival. The builders displayed a profound understanding of their environment, carving out a labyrinth that remained hidden, stable, and breathable for centuries. Their first and most critical challenge was air. Without a constant supply of fresh oxygen, such a deep complex would become a tomb in hours. The solution was a network of over 50 sophisticated ventilation shafts, some stretching over 100 meters to the surface. These were not simple holes, they were carefully placed to exploit subtle differences in air pressure and temperature, creating a passive, reliable circulation system that constantly drew stale air out and pulled fresh air in. This understanding of fluid dynamics, achieved without any formal knowledge of physics, is something modern engineers still marvel at. Then there was the matter of safety and structure. The builders engineered massive, circular stone doors, each weighing over half a ton. These could be rolled across key passageways from the inside, sealing off entire sections in an instant. To prevent collapse, they left immense pillars of untouched rock to support the ceilings, calculating load distribution with an intuition that has kept these chambers intact for over a millennium. Modern subterranean construction relies on steel reinforcements and complex computer modeling, yet these ancient architects used only hand tools and a holistic vision, treating the earth not as an obstacle to be conquered, but as a partner to be understood. They integrated geology, architecture, and environmental science into a single, seamless discipline. The patience and collective knowledge required to carve such a sanctuary, level by level, is almost beyond our modern comprehension. From these hidden underground worlds, we ascend to the very top of the world, where another civilization engineered a highway system that connected a mountain empire. Stretching across the Andes, a highway of stone and earth connected an empire. The Inca road system was a marvel of logistical ambition, a network of over 25,000 miles that conquered some of the planet's most unforgiving landscapes. It scaled vertiginous mountain passes, hugged sheer cliff faces, and then, at its most impossible moments, simply leaped across vast chasms. The solution to these gaps was as elegant as it was terrifying: suspension bridges woven not from steel, but from native grasses. These were not simple rope walkways. They were engineered structures, their cables as thick as a person's torso, painstakingly braided by hand from resilient iku grass. The entire community participated in a continuous cycle of renewal, a ritual of maintenance where old sections were replaced long before they could fail. This was not just engineering, it was a covenant with the landscape, a promise of shared responsibility that ensured the bridge's life far exceeded that of any single generation. The builders understood the dynamic forces at play, how the bridge needed to sway and breathe with the wind and the rhythmic tread of llama caravans, dissipating energy that would tear a rigid structure apart. Modern attempts to recreate these bridges using similar natural fibers often result in structures that decay quickly or lack the same inherent stability. We can analyze the braiding patterns, but we struggle to replicate the deep, accumulated knowledge of material behavior and the cultural imperative of communal care that made these fleeting structures paradoxically eternal. This mastery over land and fiber finds its ultimate expression in another form of ancient engineering, one that commanded the most vital and unpredictable element of all, the flow of water itself. While the Incas mastered suspension bridges to cross the air, another civilization performed an even greater magic, pulling rivers from deep within the earth. In the heart of the arid Persian plateau, a hidden network of underground canals known as Qanats turned desert into garden. This was not a simple ditch, but a masterpiece of subterranean engineering, a gently sloping tunnel carved by hand through miles of rock and soil to tap a distant aquifer. The genius of the Qanat lay in its profound understanding of gravity and geology. Teams of specialized workers, known as mukani, began by sinking a mother well deep into the water table at the foot of a mountain. From there, they would chart a path, digging a main channel with a slope so precise, just 1 meter of drop for every 1,000 meters of length, that water would flow steadily to the surface at its destination, without ever being too fast to cause erosion or too slow to stagnate. Along the entire length of this underground river, they dug vertical access shafts every 20 to 30 meters. These were not just for digging and maintenance, they acted as brilliant ventilation chimneys, allowing air to circulate and keeping the water clean and cool, free from the dust and evaporation that plague open canals. For thousands of years, this sustainable system delivered a reliable water supply to cities and farms, supporting entire civilizations in places where life should not have thrived. Modern water projects in similar regions rely on deep wells with powerful electric pumps, which rapidly deplete ancient aquifers and require immense energy. The Qanat, by contrast, was a model of harmony, a self-regulating system that drew only what the aquifer could sustainably yield. It represents a philosophy of working with the Earth's own logic, a depth of hydrological wisdom that our technology-heavy solutions struggle to equal. This quiet mastery over the flow of a vital resource finds a surprising parallel in the control of something just as intangible, the flow of sound itself within the heart of a stone chamber. The same intuitive understanding that guided water through underground tunnels was applied to a more ephemeral element, the human voice. In the great amphitheaters of ancient Greece, a remarkable phenomenon occurs. A single whisper uttered from the center of the stone stage can travel with perfect clarity to the very last row of seats, hundreds of feet away and high above. This was not an accident of architecture, but its very purpose. These structures were engineered as giant acoustic instruments, designed to capture and project sound without a single watt of electrical power. The secret lies in a perfect synergy of shape, material, and mathematics. The semi-circular, bowl-like shape of the theater naturally focuses sound waves inward and upward. The stepped rows of limestone seats act not merely as places to sit, but as a complex series of acoustic filters, scattering low-frequency noises like the rustle of the crowd while reflecting the higher frequencies of speech directly toward the audience. Even the slight, precise irregularities in the stone surfaces were intentional, breaking up sound and preventing the kind of echoes that would muddy the words of an actor or orator. Modern acoustic engineers can model these effects with sophisticated software, identifying the principles of wave propagation at play, yet constructing a new theater of the same scale and achieving the same flawless acoustic performance using only the materials and methods of the ancients has proven incredibly difficult. The knowledge required was not just geometric, it was sensory. The builders possessed a deep, almost musical feel for how sound would live and move within the space they were carving from the hillside. It was an integration of art and science that turned a public gathering into an intimate experience, ensuring every citizen could hear and participate. This mastery over the invisible waves of sound finds its parallel in a mastery over light and shadow, and the creation of visual precision so advanced it would not be matched for over 1,000 years. Even the most perfect line can deceive the human eye. The ancient Greeks understood this paradox intimately, and they engineered their most sacred structures to correct for it. Look closely at the Parthenon, and you will discover that nothing is quite as it seems. Its majestic columns are not straight, but bulge almost imperceptibly in the middle. The platform it stands upon is not flat, but curves gently upward toward the center. Even the spaces between the columns are not uniform, they are minutely adjusted. This entire system of intentional imperfections is known as intosses, a masterful application of optical engineering. The builders knew that perfectly straight lines viewed from a distance would actually appear to sag and buckle to the human eye. By introducing these subtle curves and variations, they forced the temple to appear perfectly straight, rigid, and majestic from every vantage point. This was not a mere artistic flourish, it was a profound mathematical achievement. It required a deep understanding of geometry and human perception, calculating how light and shadow would play across the marble surfaces at different times of day. Modern architects are well aware of the principles of intosses, yet applying this level of refined, large-scale correction in stone construction is a monumental undertaking that is rarely attempted today. We have laser levels that can guarantee perfect straightness, but the Greeks were after a higher truth, perceptual perfection. Their goal was not just to build a temple, but to create an ideal visual experience, a testament to a philosophy where beauty and engineering were inseparable. This drive to shape the land itself to achieve a perfect form finds a powerful echo in another part of the world, where ancient hands moved mountains of earth to create colossal, perfect shapes only visible from the sky. Scattered across the arid plains of Peru, a vast canvas of stone and earth holds messages meant for the sky. The Nazca lines are not just drawings, they are geoglyphs of monumental scale, depicting spiders, hummingbirds, and geometric shapes so large they can only be fully comprehended from high above. Created over 2,000 years ago, their method seems deceptively simple. The dark surface stones were carefully removed to expose the lighter, unoxidized soil beneath. But the simplicity ends there. How did the Nazca people design and execute these perfect, sprawling figures without ever seeing their work from above? The answer lies in a form of applied geometry that feels almost like magic. Researchers suggest they may have used a system of scaled models and a network of ropes anchored to central points, effectively creating a giant, functional compass on the desert floor. A small team could have laid out a perfect circle or a straight line stretching for miles using nothing more than stakes and cord, scaling up the design from a master plan through an intimate understanding of proportion and angle. The true challenge, however, was coordination. Executing a design spanning hundreds of meters required the synchronized labor of a community, with teams working on isolated sections of a hummingbird's wing or a monkey's tail, all trusting in a shared plan they could never visually confirm. Modern attempts to replicate just one of these lines using the same presumed tools and manual labor consistently fall short of the original's breathtaking precision and fluidity. The figures remain crisp, their curves smooth, and their lines perfectly straight over impossible distances, defying the natural contours of the land. This suggests a lost knowledge that went beyond simple surveying, a holistic system of project management and spatial reasoning that wove together geometry, ritual, and collective purpose. The lines stand as a testament to a culture that could encode profound meaning into the very skin of the earth, a practice that finds a mysterious echo in the intricate symbols and alignments hidden within the very stones of medieval cathedrals. Scattered across the windswept hilltops of Scotland and France stand the silent, scorched remains of ancient forts. Their stone ramparts bear a bizarre and permanent transformation, fused into a dark, glassy slag. This is the mystery of vitrification, where rock has been melted and resolidified, a process that demands a sustained heat of around 1,100 degrees Celsius. How could ancient people generate such a furnace-like intensity across entire walls, not in a contained kiln but in the open air, and to what end? The theories are as varied as they are puzzling. Some suggest it was a desperate defensive measure, an attempt to strengthen the walls against invaders by fire welding the stones together. Others propose it was the catastrophic result of those very attacks, with siege fires burning so fiercely they melted the very fabric of the fort. Yet the vitrification is often remarkably uniform, suggesting a controlled and deliberate application of heat. Perhaps it was not warfare but ritual, a symbolic act of purification or permanence, sealing a communal space with a crust of artificial lava. Modern attempts to replicate the effect have been only partially successful. Building a wood fire hot enough and long-lasting enough to vitrify tons of stone requires a staggering amount of fuel and a sophisticated understanding of airflow, creating a thermal environment that seems to defy the technological capabilities of the time. These experiments often result in incomplete fusion or structural collapse, unlike the ancient walls which, though transformed, still stand. The vitrified forts remain an enigma, a clear fingerprint of a high-temperature technique whose purpose and method have been lost to the centuries. This mastery over the very state of matter, turning solid stone into a liquid and back again, finds a fluid parallel in another ancient skill, the ability to command the flow of water itself without any moving parts. While medieval Europe would wait millennia for basic sanitation, a Bronze Age palace enjoyed the luxury of running water and flush toilets. The Minoan palace of Knossos on Crete was a marvel of advanced hydraulics, a labyrinth not just of myth but of terracotta pipes and stone conduits. This was not a crude attempt but a fully realized system for managing a precious resource. Water was channeled from distant sources through a network of carefully sloped pipes, using gravity to deliver a steady supply to fountains, baths, and even the royal quarters. Their terracotta pipes were engineered with a tapered, conical design, allowing them to be fitted tightly together, and the water pressure itself would help seal the joints, preventing leaks. But the true genius lay in what happened after the water was used. Waste was carried away through a separate, closed sewer system with stone channels that could be flushed clean. They even designed sedimentation tanks where water would be allowed to sit, letting impurities settle to the bottom before the cleaner water flowed on. This proactive separation of clean water from waste represents a concept of public health that would not become common again for over 3,000 years. Modern attempts to rebuild these systems using the same materials often struggle with the Minoan's seamless integration and longevity. We can replicate the components, but we miss the holistic philosophy, the ingrained understanding that a civilization's health is directly tied to its mastery of water's journey. This Bronze Age wisdom, born on a verdant island, finds a stark and brilliant counterpart in the deserts of the Americas, where another culture performed its own kind of water magic. Even in the driest corners of the world, ancient ingenuity found water suspended in the air itself. Across the Canary Islands and the Atacama Desert, communities did not wait for rare rain, they harvested the fog. Using vast, vertical nets made from native grasses or woven fibers, they erected these structures on high ground, precisely where wind-driven mist was most prevalent. This was not a random act of desperation, but a sophisticated application of environmental science. Generations of observation taught them the subtle language of microclimates, the specific wind patterns that carried the densest banks of moisture, and the exact condensation physics required to transform tiny droplets into a flowing stream. The captured water would trickle down the mesh into stone channels and reservoirs, providing a sustainable lifeline for both people and crops. Modern fog-catching projects use advanced polymer meshes, yet they often struggle to match the consistent yield of these ancient systems. The old methods were not just about the mesh, they were a holistic practice, a ritual of placement and maintenance that was deeply woven into the cultural fabric. The efficiency came from a slow, symbiotic relationship with the landscape, a knowledge that our technology first approaches often overlook in the search for a quick, scalable fix. This elegant, low-tech mastery over a fundamental resource stands in quiet contrast to the immense physical challenges that other cultures embraced, moving and shaping the very bones of the earth on a scale that defies belief. Granite drill cores from ancient Egypt hold a secret in their spiral grooves. Within museums lie forgotten fragments of stone, drilled cylinders of rose granite and black diorite that were discarded by artisans thousands of years ago. The surfaces of these cores are marked with perfectly consistent, deep spiral grooves, as if cut by a machine. This is the evidence of a drilling technology that was both incredibly powerful and mysteriously silent. The accepted theory is that the Egyptians used copper tubes, a simple bow to spin them, and a steady flow of abrasive sand slurry. The hard quartz in the sand would do the actual cutting, slowly grinding its way through the impossibly tough stone. Yet when modern experimenters try this method, the results are tellingly different. Their grooves are shallower, more erratic, and the process is agonizingly slow, taking many times longer than what the ancient output suggests. The efficiency of the original work implies an immense, sustained downward pressure and a rotational speed that a simple hand-powered bow seems incapable of providing. Some researchers point to the uniformity of the grooves as evidence of a fixed, weighted apparatus, a kind of ancient drill press that could maintain perfect vertical alignment and consistent force. Others speculate about the possibility of a different, forgotten abrasive, a compound that was somehow more aggressive than common sand. The ancient drillers possessed a holistic mastery, a feel for the perfect pressure, the ideal sand-to-water ratio, and the rhythmic pace that turned a soft copper tube into a tool that could eat through granite as if it were soft wood. This was not just drilling, it was a high-precision dialogue with the stone itself. How did they achieve such feed rates and perfect symmetry without any of the power sources we take for granted? This unanswered question connects directly to one of the greatest architectural puzzles on Earth, the mind-bending precision of a structure that should not exist. The silent, sun-baked limestone of Malta holds the memory of humanity's first attempt to build in stone on a grand scale. Here stand the oldest freestanding structures on Earth, the megalithic temples, erected over 1,000 years before the Great Pyramid of Giza was even a concept. Their massive blocks, some weighing over 50 tons, were quarried, moved, and meticulously stacked into complex, cloverleaf-shaped sanctuaries, all without the leverage of metal tools or the power of the wheel. The methods employed were a symphony of simple physics executed with breathtaking ambition. We can envision teams of workers using wooden levers to coax each colossal block onto a bed of log rollers, inching it across the landscape through sheer, coordinated muscle. Some researchers suggest they may have used a slick pathway of wet clay to reduce friction, or perhaps even floated the stones on barges during periods of higher sea levels, turning the Mediterranean itself into a highway. Yet, understanding the individual steps does little to explain the whole. The true, staggering mystery lies in the coordination, the project management required to orchestrate hundreds of workers in the precise fitting of these multi-ton puzzle pieces. Modern experiments using only replica tools and human power consistently fail to match the scale and accuracy of the originals. Teams struggle to move blocks even a fraction of the weight, and the final placement never quite achieves the seamless fit seen in temples like Haga Kim or Mnajdra. This was not merely construction, it was a societal act of faith, a leap in architectural ambition that required a shared vision and a generational commitment to a plan no single person would see completed. The temples are a testament to what a coordinated community can achieve, a principle that would soon be applied to an even greater challenge, the birth of the world's first planned cities. The same impulse to organize society for the common good found one of its earliest and most perfect expressions not in grand monuments, but in the quiet logic of a city street. Mohenjo-Daro, rising from the Indus Valley plains around 2,500 years before the Common Era, was a marvel of premeditated harmony. Its streets were laid out in a near-perfect grid, a pattern of such deliberate order it feels startlingly modern. This was not a settlement that grew organically and chaotically over time. It was built to a plan, a single, sweeping vision of urban life executed with breathtaking consistency. Every brick, from the grand structures to the humblest home, conformed to a standardized ratio, a universal module that allowed the entire city to be built as a cohesive whole. The planning required a level of advanced surveying and a shared system of measurement that unified thousands of workers and generations of builders. But the true genius of Mohenjo-Daro was not just on the surface, it was hidden beneath it. A complex, city-wide drainage system channeled waste away from homes and public spaces through a network of covered brick channels. each equipped with inspection traps and manholes for maintenance. This was a society that had elevated public health to a core principle of civic engineering, a concept that would be lost and rediscovered millennia later. Modern urban planners look upon its efficient layout and integrated infrastructure with a sense of awe, yet attempting to build a new city with the same level of holistic harmony, using only the tools and materials of the Bronze Age, presents an almost insurmountable challenge. The achievement points to a sophisticated, centralized authority, one capable of orchestrating a long-term project for the welfare of its entire population. This deep-seated need for communal order and protection finds its most powerful and enduring expression in the formidable walls that have defended civilizations for millennia. A fortress was more than just a wall, it was a three-dimensional trap for the mind. Look at the Lion Gate of Mycenae, where any attacker was forced to approach the main entrance with their unshielded right side exposed, all while being watched from above by the stone gaze of two lionesses. This was psychological warfare carved in stone. The defensive architecture of ancient citadels like Mycenae and Hattusa was a masterclass in holistic thinking, weaving together terrain, material science, and a deep understanding of human instinct. Their walls were not simple barriers but layered systems of death traps. Baffled gates forced invaders into narrow, twisting corridors where they could be attacked from three sides at once. Parapets were designed with slanted tops to deflect incoming projectiles, and strategic blind spots were engineered to lure attackers into kill zones. This was not a brute force approach, it was a subtle, brilliant manipulation of an enemy's movements and morale. Modern security often relies on standalone elements, a strong perimeter fence, surveillance cameras, and reinforced doors. But these ancient builders thought in terms of interconnected systems, where the very shape of a passageway was a weapon, and the choice of building stone was a tactical decision. Recreating such a deeply integrated defense today using only period methods would require a lost school of thought, one where the architect was simultaneously a general, a psychologist, and a geologist. This seamless fusion of practical function and profound artistry finds its ultimate expression in another discipline, where engineering was used not to repel but to elevate the human spirit. To cast a giant in bronze required a ritual of fire and earth that walked a razor's edge between triumph and catastrophe. The lost wax method for large-scale statues, perfected in ancient Greece and China, was not a single act but a series of calculated risks, each step a potential point of failure. It began with a detailed clay core, the statue's internal skeleton. This was then meticulously covered in a layer of beeswax, sculpted by the artist's hand into every final muscle, tendon, and fold of drapery. The entire assembly was then entombed within a thick, heat-resistant clay mold, with small wax rods added to create channels for the molten metal to flow and for gases to escape. The moment of truth came with the firing. The mold was heated, and the wax was not simply removed. It was lost, melting and draining away to leave a perfect, hollow negative space between the core and the mold. Into this fragile cavity, a searing river of liquid bronze, heated to over 1,000 degrees Celsius, was poured. The challenges were immense and interconnected. The clay core had to be perfectly dry, as any residual moisture would instantly turn to steam, exploding the mold from within. The molten bronze had to fill the entire, complex cavity in a single, continuous pour, requiring a coordinated team of smelters and a furnace operating at peak efficiency. Most critically, the artisans had to master thermal expansion, anticipating how the different materials, the clay mold and the cooling metal, would shrink and shift at different rates. A miscalculation by even a millimeter could result in a catastrophic crack, a misaligned feature, or a weak point that would fail under the statue's own immense weight. For truly colossal works, like the legendary Colossus of Rhodes, the statue was cast in separate, manageable sections. The final assembly was another high wire act, using a form of ancient brazing where the joints were heated and fused with a lower temperature metal alloy, a technique requiring a flawless feel for the material's behavior. Modern foundries, for all their advanced kilns and computer modeling, often struggle to achieve the same combination of artistic subtlety and structural integrity on such a grand scale. We can replicate the steps, but we have lost the intimate, generational knowledge of how to listen to the metal as it cools, to feel the stresses in the mold, and to guide this volatile conversation between earth, wax, and fire to a perfect conclusion. This profound mastery over Earth's raw materials finds its ultimate expression in the most fundamental of all ancient arts, the very act of shaping the landscape itself to sustain human life. These mountainsides were not merely farmed, they were rewoven into life. The Incas transformed the steep, punishing slopes of the Andes into a cascading series of green stairways, agricultural terraces that clung to the mountains like a living garment. This was not simple landscaping, it was a profound act of geoengineering, a dialogue with the land that created fertility from sheer rock face. Each terrace was a complex, layered system. The first step was building a retaining wall of perfectly fitted stone, strong enough to hold back tons of earth and withstand centuries of rain and tremors. Behind this wall, the Incas did not just dump soil, they built it layer by layer like a cake. The bottom was filled with coarse stones for drainage, followed by layers of finer gravel, sand, and finally, a rich topsoil meticulously prepared with organic matter. This prevented waterlogging at the roots, a death sentence for crops at high altitude. But the true genius was in the water management. They integrated the terraces with canals and aqueducts that captured mountain spring water, channeling it to each level with a gentle, controlled flow that nourished the plants without washing the precious soil away. This intricate understanding of hydrology allowed them to create multiple microclimates on a single mountainside. A terrace facing the morning sun would grow one set of crops, while another, shaded in the afternoon, would support something entirely different. They were effectively farming across different climatic zones within a short walk, achieving a biodiversity that modern industrial farms struggle to match. Today, agricultural scientists look to these ancient methods as a model of sustainability, attempting to replicate their resilience against soil erosion and their efficient water use. Yet, achieving this same seamless integration without the use of heavy machinery and with only an intimate, generational knowledge of the local environment is a monumental task. The Incas did not fight the mountain, they listened to it, and in doing so, they built a system that fed millions in harmony with the world's most rugged terrain. This earthly harmony finds its perfect reflection in the skies, mirrored by structures built not for survival, but for the soul. High above the jungle canopy, a stone snail shell turns its gaze to the heavens. El Caracol at Chichen Itza is more than a ruin, it is a sophisticated astronomical machine. Its unique circular tower, set upon a broad rectangular platform, is pierced with narrow slots and aligned with precise celestial events, most notably the extreme positions of the planet Venus. For the Maya, Venus was not merely a bright light in the sky, it was a deity, and its complex 584-day cycle dictated the timing of warfare, agriculture, and sacred ceremonies. Tracking this cycle required not a single observation, but generations of unbroken data collection. The entire structure is a physical manifestation of that long-term commitment, its architectural angles and sightlines refined over centuries to correct for the subtle wobbles in planetary motion. Modern researchers using replicas of the simple tools available to the Maya, like crossed sticks for sighting and knotted cords for measurement, can approximate some of these alignments. Yet they consistently miss the nuanced calibrations, the tiny offsets in a window frame, or the specific thickness of a wall that would have accounted for atmospheric refraction or the observer's own height. These were not static designs, they were living instruments, constantly fine-tuned by a priestly class who saw the careful recording of the cosmos as a sacred duty. This profound, generational investment in celestial science reveals a civilization that viewed time as a divine, cyclical force to be understood and honored, a perspective that stands in stark contrast to our own. From this lofty pursuit of cosmic order, we descend back to the Earth, to a mystery locked within the metallic bonds of a metal that should not exist. A liquid flame that could not be quenched by water gave the Byzantine navy an almost mythical power. In the heat of naval battle, a terrifying jet of fire would erupt from a bronze tube mounted on their ships, a weapon known to history as Greek fire. This was not simple burning oil. It was a sticky, liquid concoction that clung to enemy ships and sails, igniting upon impact and creating an inferno that water seemed only to spread. The terror it inspired was as potent as the flames themselves, a psychological weapon that secured the empire's maritime dominance for centuries. The secret of its composition was so closely guarded that it died with the empire, becoming one of history's most enduring chemical mysteries. Modern analysis suggests a base of crude petroleum, possibly from surface wells around the Black Sea, combined with other ingredients like resin to make it adhesive and quicklime, a substance that generates intense heat upon contact with water. This last component might explain its fearsome reputation for being water-resistant, as dousing it could have actually intensified the reaction. Contemporary chemists have proposed numerous formulas, creating substances that burn fiercely, yet none have reliably matched the historical accounts of a self-igniting, persistent fire that could be projected in a continuous, liquid stream from a siphon. The missing ingredient may not be a single chemical, but a lost art of processing and combining them, a specific sequence of mixing, a particular grade of crude oil, or an additive like saltpeter that altered its fundamental behavior. This was not just a recipe, it was a sophisticated piece of chemical engineering, a product of controlled, volatile reactions that required a deep, practical understanding of materials no textbook had yet defined. It stands as a stark reminder that ancient innovation could be as formidable in its capacity for conflict as it was in creating beauty and longevity. This final mystery brings us to a place where many of these threads intertwine, a single object that encapsulates the pinnacle of forgotten engineering. A corroded lump of bronze and wood, salvaged from a 2,000-year-old shipwreck, held a secret that would rewrite history. This is the Antikythera Mechanism, an ancient Greek device so advanced it has been called the world's first analog computer. Far from a simple calendar, it was a miniature bronze universe, its intricate interior a complex clockwork of at least 30 intermeshing gears. By turning a hand crank, an operator could predict the positions of the sun, moon, and known planets, forecast lunar and solar eclipses, and even track the cycle of the ancient Olympic Games. Its dials and scales represented a fusion of astronomical knowledge, complex mathematics, and precision engineering that should not have existed for another millennium. The device required its creators to understand the subtle irregularities of the moon's orbit, a concept known as lunar anomaly, which they modeled using a beautifully ingenious pin and slot mechanism that allowed a gear to speed up and slow down, mimicking the celestial dance above. Modern researchers using X-ray tomography have spent decades just to map its mangled workings, and building a functional replica using only the tools of the era, like hand-powered drills and files, reveals the staggering level of skill involved. Each gear had to be cast, then hand-finished to microscopic tolerances, with tooth counts corresponding to precise astronomical cycles. The full scope of its functions is still being uncovered, a testament to a peak of technological sophistication that was lost to the world for centuries, its secrets sinking to the bottom of the sea. So what connects this intricate bronze computer to the self-healing Roman concrete, the walking Moai, and the celestial pyramids? A common thread of deep, patient observation. These were not technologies born from sudden inspiration, but from generations of watching the stars, feeling the grain of the stone, and listening to the whispers of the natural world. They represent a different kind of genius, one rooted in harmony with the environment and a long-term conversation with the materials at hand. The legacy of these 25 methods is not just a list of puzzles, but an invitation to look at our own world with the same reverence, to see that the most enduring engineering may not fight against nature, but learn to move with it. These 25 marvels of the ancient world are not a random collection of isolated mysteries. They are individual notes in a grand, harmonious symphony of human ingenuity. When you step back, clear patterns emerge, revealing a universal philosophy that connected cultures separated by vast oceans and centuries. The most profound common thread is a deep, patient observational science. These builders did not seek to conquer the natural world, but to understand its rhythms and work in partnership with it. The Roman concrete that heals itself with seawater, the Inca terraces that farm the mountain without eroding it, the Qanats that gently pull water from the earth without depleting it, all speak to a sustainable, long-term vision. This was engineering as a form of dialogue, a constant conversation with the material and the environment. Another unifying principle was the transmission of knowledge through community and culture. The intricate joinery of Chinese pagodas, the woven grass bridges of the Andes, and the celestial alignments of Maya observatories were not the work of a single genius, but of generations. Skills were honed through practice, passed from master to apprentice, and embedded in the very rituals and stories of the people. This was a living knowledge, refined over time and held collectively. This stands in stark contrast to our modern reliance on technology, which can sometimes distance us from a tactile, intuitive feel for our materials. We have computers that can model stresses, but we have lost the hand's ability to feel the perfect fit of a stone. We have powerful machinery, but we lack the generational patience to make an 80-ton statue walk. The spiritual dimension cannot be ignored either. For these cultures, engineering was rarely a purely secular act. A pyramid was a gateway to the stars, a temple was a map of the cosmos, and a vitrified fort might have been a symbol of permanent protection. The functional and the sacred were woven together, creating works that served the body, the community, and the soul simultaneously. This integration gave their creations a resilience that goes beyond the physical, a purpose that ensured their care and preservation for ages. So what does this mean for us today? These ancient methods are more than historical curiosities. They are a mirror held up to our own approach to innovation. They challenge our obsession with speed and power, inviting us to consider a slower, more thoughtful path. They ask us to value the wisdom of the hand as much as the power of the processor, and to seek solutions that are not just effective for today, but harmonious for the millennia to come. Our journey through these 25 hidden methods reveals a world where human ingenuity did not simply precede our own, but often charted a different course entirely. It is a profound reminder that knowledge is not a straight line of accumulation, but a tapestry that can fray, with entire threads of understanding lost to the passage of time. These enduring mysteries challenge the very narrative of linear progress, forcing us to appreciate a different kind of intelligence, one born from deep observation and a harmonious relationship with the natural world. As modern science continues to decode these ancient feats, we are offered more than just answers. We are given a new lens for our own future. The self-healing concrete, the sustainable water harvesting, the seismic-resistant joinery, all point toward a philosophy of resilience and sustainability that our era desperately needs to rediscover. The true legacy of these master builders is an invitation to innovate not by overpowering our environment, but by learning from its timeless logic. We thank you for exploring these enigmas with us. We would love to hear which of these 25 hidden methods captured your imagination the most. Share your thoughts in the comments below and subscribe for more journeys into the forgotten wonders of our